So we're going to do a quick demo of Mathematica here. So the environment looks like this, and you can do calculations by doing something, for example, 2 plus 2, and then you hit Shift-Enter to do a calculation. There you go. So it'll tell you that this is actually the second input that I've run. That was 2 plus 2. And then this is the second output, 4. You can refer to that, but I never do, so you don't really need to. So what can you do in Mathematica? Just as far as the editor itself goes, you can type equations like we've seen. There are also other types of cells. So if you go into cell types somewhere, convert to maybe. There's different forms. So there's input form and others. The ones that I use are, there's a text form and a computation form. So what I end up doing is Alt-7 is what switches you to text form, right? So to switch to text form, use Alt+7. For headings, use Alt+4. And then the default mode is math mode. What else? You can make new cells just by moving your cursor between two existing cells. And you can see cells on the right. Okay, so over here are the different cells we've been using. These are grouped. You can open and close them just in terms of if you want to hide the output or something. You can also delete things if you don't want them. And then you can also make nice headings. So introductory remarks. There you go. And that gets automatically grouped. And let's close that up. So next up, let's do some basic graphics. So for basic graphics, there are two main tools. There are two main tools that I use, at least. There's a lot of different tools. So there's graphics, and there is parametric plot. These are for 2D, and there's also a 3D version of each. So there's graphics 3D and parametric plot 3D. Okay, graphics shows basic geometric objects such as lines, dots, etc. And parametric plot shows parameterized curves or surfaces in 3D. All right, so let's have some examples. So I can have graphics. I could have a line, and then what I want to remember is that lists are made using squiggly braces, right? So not parentheses, use squiggly braces. So a line object takes a list of points. So I could have a line that starts at 0, 0, goes to 1, 0, then proceeds to 0, 1, then goes to 1, 1. Or actually, I want it to go 1, 1, then 0, 1. So you might recognize that as the square. It's in fact not a square. It doesn't close it up automatically, so you add that last vertex, 0, 0, to close it off. So there you go. You can adjust the settings a little bit. So for example, you can say plot range should be, maybe I want to see this in a bigger picture, so maybe I want to have it -5 to 5, and then -5 to 5 again. And that gives me a bigger space that I can show things in. What else? If I want to see options, so for example, I can do something like this. Tells me some quick information about the graphics command. If I click on graphics and hit F1, or if I click on this arrow, then it'll give me the full user page. or the full manual page, and there's lots and lots of objects that you can do, that you can show. So lots to explore there. And here you can do line, for example, right? So you can see it takes a list of points. You can do multiple lines by doing multiple lists of points. There's lots of options in terms of making thick lines, dotted lines, and so on. So lots of things there, and it'll also show you different examples of how to use this. So the documentation is quite good.
That's great.
So that's graphics, and then let's do parametric. Parametric plot. There you go. It does auto completion. So this is where I can specify, for example, that I want something that maybe does cosine t, sine t, is going to be my function that takes the variable t to the space coordinate cosine t, sine t. And then I need to specify bounds on t. So t maybe is going to go from 0 to pi over 2. And the way I made that pi just now is, you can just write, I believe capital pi will give you pi. If you want something that looks nicer, what you do is you hit escape, you write pi, and then you hit escape again, and that gives you those special characters. You can also go back, and rather than doing over 2 this way, you hit control divide, and that'll give you a fraction. So you can do something like this. So that's parametric plot. So that'll take our angle coordinate from 0 to pi over 2 and plot half of a circle. There you go. And again, there's lots of options. You can hide the scale. You can pick, what the numbers are on the scale. But I won't go into that right now. We can also do something where we show multiple things at the same time using the show command. So here's the graph, the box that we made before. Here's the parametric plot we made, and here they are displayed together. Okay, and again, you can use that plot range to specify, in this case, for the show function. You can specify what that plot range is. Sometimes you get something where it doesn't, it picks the size based on the first thing that you're showing. So a really useful option is plot size automatic, which you would assume is the automatic option, but it's not. All right, so that's plotting basics. Okay, so basic graphics, let's close that up. Next up is functions. So how do I make functions? You say something like f, you specify the variables, so f of t. You would expect it to be something like this. Cosine t sine t is the function that we used before. That is not the notation that Mathematica uses, so you have to put an underscore after your t, then you have to put a colon here to make a function. And now you can do something like f of pi gives you -1, 0. So that's really convenient for making new functions, and you can give it, you can make something like t and s, or let's do polar coordinates just for fun, r and theta. You can do something like this, maybe 2xy from polar, cosine theta, sine theta, and then maybe you multiply that by r. So there you go, 2xy from polar of 1 pi over 4. There you go. Outputs that vector. You can switch, if you would prefer to see an actual numerical solution. Mathematica is really good at symbolic computation. That was kind of its thing when it came out. If you want to see it in numerical mode, what you can do is you can apply the n function to that output, and that'll kind of chop off and give you a numerical approximation. Another thing you can, another way to do that is to take this and this kind of a postfix notation. So it says do this stuff and then apply n to it. So it does the same thing. So a lot of times what I'll do is run a command and then say, okay, I want to see that in numerical form. So that's functions. Other thing you might want is, for example, let's go back from polar, right? So to polar from x, y. So now I'm thinking of x, y as a pair. So I might think of it as a pair like this. So notice that before I was specifying two variables that were just two variables. I can also specify that the input is a list with two variables. So then again, I would do something like norm of xy, and then I would do arctan. So in Mathematica, arctan, there's a 2-parameter version of arctan, and it's in the order xy. I think in C++ it's in the order yx, which is confusing. So you can make something like this. And then 2 polar from xy, 1, 1. There you go. There's the root 2 pi over 4. What else could you want to do? You could have that list, right? So if I have a list, I might want to extract the first element. To extract an element, I do double brackets. And Mathematica is weird. It starts counting at 1, unlike all other civilized languages. Okay, so to get that square root of 2, I have to tell it to take the first element, not the second element. And then likewise, I can take the second element. I like, again, to make things pretty, what you can do is you can do escape, double brace, escape, double brace. That looks a little bit neater. Same functionality, but a little bit more compact. Let's see, to make the square root, right, so quick shortcuts, square root. Root is alt plus 2. So, no, it's not. It's control 2, control 2. It's kind of funny. You get used to them, and then you don't know what you're pressing anymore. Powers is control plus 6. So I could do something like this. What does it do? Nice. All right. What else is there? Divide. So fractions are control plus this, right? So over 2. Okay. And then Mathematica does some simplifying automatically, but you can always tell it to simplify using simplify. Okay, simp. There you go. So simplify. All right. So that's basic functions. You can also do matrices if you like. To make a matrix, just make a list of lists. So 1, 2, 3, 4, that would be a vector, right? But if I make a list of lists, then that's a matrix now. I can put it in matrix form like this. Okay. Use matrix form to view, but only to view. Okay. So if I try to multiply two things that are in matrix form, it gets unhappy, which is, I don't know, they should fix that, I think. And then you can do things like 1, 1, 0, 1, dot 1, 1, 0, 1. So dot is my notation for matrix multiplication. I'm in math form, or I wasn't in math form, but there you go, right? So I started off with a matrix 1, 1, 0, 1, and then if you dot it with 1, 1, 0, 1, you get 1, 2, 0, 1, which is nice. So that's, and then you can do the same thing, right, with vectors, right? So I could do this thing. Let me call that A is this. Then I could do A dot XY, and that'll do that dot product, or that matrix multiplication. I can always do things like eigenvalues of A. It'll calculate those for me, or eigenvectors of A. So that's fun.
The matrix, so you can dot two matrices together as long as they're not in that matrix form. It's the matrix form that causes the issue, not
I think if you do like matrix form of A dot matrix form of A, it like just doesn't do it.
Okay, sure.
Yeah, so matrix form is just for viewing. All right, so that's basic kind of functions and slightly more advanced functionality, so functions and matrices. And then the thing that I love about Mathematica is manipulate. This thing is great. So what you can do is you can do manipulate. You tell it some stuff. So for example, maybe I want to do x squared. And then you tell it what you want x to be. So maybe I want x to be between 0 and 1. And it gives you a little slider where it's, let's make it between 0 and 10. Right, so it's a little bit more obvious what's going on. And maybe I want to have it move in steps of 1. And I can show what x is here. And I can even just tell it to autoplay. Okay. And the fun of this comes when you do something like, let's see, how do I make a circle? I think circle, center and radius, right? So I could make, could do the following. I could make graphics, circle. Maybe it's going to be based at cosine theta, sine theta, and it's going to have radius, I don't know, let's have it have radius 0.1. And then we're going to have theta go from 0 to 2 pi, and it's going to go in sizes of, I don't know, pi over 12. So we're going to show that off. And then, so here's what happens. Okay, not very exciting because each time it's just showing that circle. So the axes are changing. So what I need to do here is change the plot range so that it's like -1 to 1, -1 to 1. So now that circle is going to move around like this. Okay. Maybe I want to make it a little bit bigger so that I actually have space for my circle. There you go. And we can make it more entertaining. So let's also provide an arrow that goes from 0, 0 to the center of the circle. So it'll go to here. So arrow requires a list of coordinates. Okay, so now we have that arrow. Maybe I want the circle a little bit smaller so that it's kind of at the end of the arrow. There you go. And then you can do things like also add text. So you can have something like up text. How does text work? So text. So expression and coordinates. So I could have something like it tells me what the coordinates are and where is it going to be? It's going to be at those coordinates. So there you go. Maybe I want to move it up a little bit plus 0.2. Oh, change the text, not the location. There you go.
Well, and with that text, could you also use the modifiers of like //n?
Yeah, so I could do something like, I would do it this way. I don't know if you could do the //n.
Okay. All right. Gotcha.
Yeah, I don't know if you can like use that in the middle. You can apparently. Okay.
All right.
Yeah, we kind of need a little bit more space here to make this look nice. All right. So that's kind of the basics. There's obviously a lot more stuff you could do. One thing to watch out for here is that with graphics, if you give it a list of things, then it should have the squiggly braces around it. And then you can do the same stuff in 3D. So you can do parametric plot 3D. Let's, I don't know, cosine theta, sine theta, theta, and theta is going to go from 0 to, I don't know, 4 pi. Gives you a nice spiral. I was running yesterday into the trouble that I couldn't rotate this very well, so let's change the plot range. Ooh, what are my options? Full? What does that do? No. That's not very useful. I wonder what the difference between all and full is. Yeah, it's not very good. So let's do -5. Let's do -4 to 4 or 0 to 4.
Yeah. To negative.
Oh, wrong one. I'm very good at this, obviously.
Professional.
Okay, and then if we, my students yesterday were asking for a double helix, so what I can do is I can do two things. So these would be the same helix, but I can shift this one by pi. So there you go. There's our double
Very
helix.
cool. Wow.
Okay. And then we can also do something silly like manipulate this with t0 to 2 pi. We can make it spin. It'll be fun. Oh, and I don't want it here.
Very cool.
Right, so you can make a nice spinning double helix. And then you can even, let's see, I think you can, I forget how to export this, but what you can do, you can certainly take a snapshot. And what I end up doing is, let me save this just on my desktop as a demo. So what I like to do, it saves in the most bizarre places. So what it's nice to do if you're saving things is, let me make this, yeah. What you do is you set directory to notebook directory. And now it's actually going to save onto the desktop as opposed to some unknown location somewhere. And then export, you tell it what sort of file you're saving to, and then you give it the thing that you're saving. So for example, let's make this tiny. So I would export to double helix.png.
Wow.
Okay. And so, okay, that gives us a very small double helix, but we can make it better by doing something like plot points, I believe is the one I tend to use. No, image size. 1024, I think that should do it. There you go. There's our double helix.
Wow.
Okay,
Okay.
so you can make things pretty quickly. I think if you want to make a GIF out of something like this, so what you would do is you would, so let's pause the manipulate. I think you take something like this and you make something like this. Right, so I'm going to make a table of things with t parameters. So, and then I don't want to actually see the output, so I'm going to put a semicolon at the end. So that's going to make the frames. Let's actually see what it is. Okay, so I've made a bunch of frames. Maybe I want to specify that this should be at like pi over 100 so that I get a lot of frames. And then I could do like length of frames to make sure, yeah, I got 201 frames. And then I think what I can do is I can do export double helix.gif frames.
No way.
Well, let's see what it does.
Yeah.
It's taking its sweet time. Is it?
So when does it actually export the file? When you hit enter on that line?
Yeah.
Oh, wow.
Okay, so it says it's done. Let's see it. Okay, there's our double helix.
Incredible. That is amazing.
Okay, and I think we can change the frame rate as well. So if we search export, then yeah, so there's examples like this. Also, there's a more direct way to do it as well. Okay. I think if we search for GIF, it'll tell us more about how to export it. Basic examples. I think there's like a frame rate option. So export options. Maybe not. I don't know. I thought there was a frame rate. Let's see. Mathematica frame rate GIF. Okay, there's a display duration. Anyway, and then you can also, if you want it to be an AVI instead, you do that.
Sure.
And it'll make an AVI for you. So you can actually make something and then you can upload it to YouTube, for example.
That's awesome.
And you can see that it's calculating over on the right here. That turns black. Let's see. Okay, that resolution is horrible. So again, we probably have to tell it, you know, image size 1024. And here's where it's calculating.
Oh, I see.
Okay, so let's make a new heading here. So exporting images and video. All right, and then I think I can do like, this is Mathematica tutorial, and then up. Mathematica basic functions and exporting images, video.
Would you go over just one more thing, and that is the use of, I've seen the use of conditionals and looping. Would you just touch on that really quick?
Yeah, definitely. And this is, what's the date? It's September 22nd, 2020. All right. Yeah, let's do conditionals and loops. So Mathematica really prefers, so conditionals are easy, right? So if you do if 1 is less than 0, then hi, otherwise bye. Okay. So if that statement is true, then it goes with this one. If it's false, it goes with this one. You can do for loops as well. So for I equals 1, I believe it's like this. Print I. There you go.
Okay.
Okay. And you don't have to specify types in Mathematica. Everything's, loosely typed.
Yeah.
Mathematica doesn't like for loops. I mean, it's got for loops, it's got while loops. Kind of the way to do it is similar to what I guess MATLAB does. So it likes lists. So you can do something like, here's the first 10 numbers. And what you can do is you can print so that yeah, so it applies something, right? Or you can do something like I can make a function that is called square of x is going to be x squared, and I can do something like square. I'm going to apply that function to that range. So that's the /@ command. You can also, I think you can do apply square range 10. No.
Okay.
Apply. Yep. Oh, it's map. There you go.
Wow. Okay.
So that's the same. And then, so that's kind of how you want to do things, is sure. Using this sort of functionality. And this is where implicit functions become really useful. So what you can do is we can define the square function implicitly as follows. So you do hashtag squared, and then to indicate that you're done, you put the ampersand. And then you can apply that to this. So this is the squaring function. So the hashtag here is the input, and then this just says I'm done defining the function. And then what we're doing is we're applying that to each of the things. Or you can do something like, you know, hashtag, the first element of the hashtag plus the second element of the hashtag. And I can apply that. Maybe I have a list that just has 1 and 2 in it. So it turns that into 3. Or I could even just take that function and apply it to this. So that gives me the addition function. All right, is that clear enough? It's kind of a weird concept.
Oh, yeah. Yeah.
Okay, anybody else? I want to make sure I don't lose everybody else. All right, so that's really convenient. You can do a lot of stuff with it, but you want to make sure that you write the code nicely. This is where Mathematica has a lot of potential for making completely unreadable code, is if you use a lot of these implicit functions and a lot of applies, it just becomes a mess. So you want to make sure to space things out nicely. And then if you want to write complicated functions, for example, if you want to have internal variables in your function, then you would do something called a module. So you could make a complicated function that's going to take x, and it's going to be a module. It's going to have a variable called y, and then it's going to do things like, I don't know, y equals x plus 1, and it's going to return y. So complicated function of 2 returns 3. So you use semicolons to separate things, and then your output is the last thing that you did in semicolon, and your variables hide in here. And you can do all the usual things. You can, I think, what is it? Like this, you set default values. So then you can do like complicated function. Yeah, so that's your default value. But let's get rid of that. So that's the basics. Last thing is, if you want to stop your evaluation, so sometimes there's hiccups. If you want to stop the evaluation, you go into,
Oh, yeah.
so you can quit the kernel, so that will just quit out of everything. And you can also abort evaluation if there's a particular evaluation that's just taking forever.
Sure.
Alt period is what you want to do, or go into evaluation, abort evaluation. If you quit the kernel, you know, I quit the local kernel. Now everything that I did is invalidated, right? These things have turned blue because it doesn't know what I was doing anymore. I can make a new kernel by just running anything, and then, you know, it doesn't know what complicated function was. I can just select all the cells and just run all the cells simultaneously, or I can run a block of cells. So here maybe I just want to run the conditionals and loops again, and that'll run those.
Oh.
I'm not running everything because I don't want to re-export all my images and video.
Of course.
Though I do want my double helix. Oh, did I get my double helix in higher resolution? I did. Beautiful.
Wonderful.
Okay, so we can use that to advertise now. Control Shift G to ungroup things, I believe. No. Grouping, ungroup. That didn't do what I wanted. Maybe here I want to ungroup. In any case, so that's the basics. Anyone have any questions about anything else that you might want to do?
I just had a quick question on the 3D parametric function. Are you able to pass in like 2 parameters? So could you have like an S and T and then have it like?
Yeah, you can. So you can do something like, where was my parametric plot 3D?
Did you move it under image?
Yeah, I think it was under exporting images, right? So here, maybe it was under manipulate. Yeah, there it was. Yeah, so I can also do something like yeah, so S and T is going to go from 0 to 1. And I don't know what I want to do. What do I want to do?
Change the radius, maybe? I don't know.
Yeah, so maybe, yeah, let's do that. So let's just have the one helix to simplify the notebook. And then T. And let's leave this one theta. Oh, that's pretty.
Cool.
Neat.
Okay. And then there's also, there used to be something called implicit plot. I think it's now called contour plot. So you can do something like contour plot 3D, x squared plus y squared minus z squared equals 3. X from -10 to 10, y from -10 to 10. There you go.
Neat.
So lots of cool stuff you can do. And it's a contour plot, so you can tell it to plot multiple. What happens if I do this? Yeah, there you go. Ooh, that's cool.
Oh.
Yeah, so maybe I want to have both of those available. So the basic one is where you specify that it's equal to something. And then if you want something that shows you a few different levels sets, then you just leave it blank. So let's actually move this into so the manipulate I want separate, and then this I can move into the plotting. There you go. All right, so thanks for watching.